You heard it right here, right now from the beach.
The new ivory is mammoth.
What do you guys want to know? I've done way too much research on dinosaurs.
Almost a larger-than-life figure.
No reason at all to think it was made by aliens.
Drop down and go swimming as fast as you can. Out of whale.
All these big giants give me a kiss and tell me they don't.
The crowd, just the pot, the loudness, the excitement, the electricity. I don't know if I can take your little Canadian destroyer.
Future is scary, but it's also wonderful. Welcome to the Unscriptify podcast, where Jedi meets Uncensored, powered by Jägermeister. In this episode, we are on another time travel, once again to the prehistoric time when giants roamed Earth and ruled skies, time of dinosaurs. In this episode, we are honored to have renowned paleontologist joining us from the Carthage College, most famous for his work on tyrannosauroid dinosaurs, Dr. Thomas Carr. Thomas, thanks for coming, and are you ready to dive deep into prehistory?
Thanks for having me.
Yeah, thank you for being here. I will ask you what I've asked every paleontologist we had on this podcast so far. How did you became a paleontologist? How you fell in love with with what would some describe as this dead world? No pun intended. I just want to sound poetic, but was it a boyhood dream come true or something else?
I was first interested in dinosaurs when I was around 2 years old through the medium of printed books. So fairly ordinary, I guess. But the interest did stick. I mean, I was 2 years old and that didn't go away. And that interest did wane a bit during my tween years, but then came back with a vengeance when I was around 16. When I was 18, I went and I volunteered to dig dinosaurs with the new Turtle Museum of Paleontology, as it was then called. And I volunteered for, I guess, a total of a month and a half in Dinosaur Provincial Park in the summers of 1986 and 87. And in the meantime, I also started volunteering in the lab at the Royal Ontario Museum. And the first dinosaur bones I prepped from a field jacket was, I think, a section of duckbill femur from Mexico. And so shortly after that, my interest became academic. And in 1988, I actually decided that I would study Tyrannosaurus for the rest of my life, or they would be the focus of my scientific interests. And so that's really how the career was born. It was a fairly linear process.
Yeah. We spoke about other paleontologists, and I think Philip Curry especially mentioned how important are volunteers in this process of digging out skeletons. And you are more than familiar with field work, excavation camps. What would be the most challenging experience on top of your mind you had on your exhibitions digging out dinosaurs? Because it's not like in Jurassic World and Jurassic Park.
Sometimes it can be. A few summers ago, I found a T-Rex tibia and fibula in a loose sand, and so we were just using brushes to brush sand away from those bones, just like in the opening scene of Jurassic Park. But it's not always like that. And collecting dinosaurs, like big dinosaurs, like I do in the Hell Creek Formation, it's a lot of work. It's labor intensive. The hours are long. It's very physical. And we depend on volunteers. Like the majority of our field crew is made up of students and volunteers. And without them, we'd be lost. We wouldn't accomplish anything. We generally have a field crew of 15 people. Sometimes it's a bit more. And 15 is enough to keep 2 quarries going. So we're usually digging 2 dinosaur quarries each field season. We divide our time between the quarries in the morning when it's cooler, and then we prospect for new fossils in the afternoons. And it can get really hot. But the challenge is having enough hands on shovels and enough eyes on the ground to keep dig going and to find new fossils. It's just finding dinosaurs is mostly a matter of probability, and you want to increase the probability that you find new fossils instead of overlooking them. So we need the numbers, and those numbers come from volunteers in large measure. And also, we rely on volunteers in our lab. We do have student volunteers. We have volunteers from the local community. If we get a grant, we can usually hire a student or an alum to prep fossils, but most of the people in our lab are volunteers, and they get recognition for that. So there is, there is reciprocity involved. Students get letters that summarize their accomplishments in the lab that will, say, help them get jobs or, in their applications to graduate school, those sorts of things.
Let me ask you this. When I was younger, I was always curious and even confused in some sense with how the whole process of searching for dinosaurs, especially in this area that we are living in, Montenegro, and around us, the region and whole. I was always curious, why is Europe less rich with fossils and dinosaur skeletons than, for example, Asia, Mongolia in particular, Alberta, Canada, and similar, South America and similar.
Right.
Is there a particular reason?
Yeah, most of that's controlled by geological history. And so in the American West, we have a unique situation where we have the uplift of, say, the Rocky Mountain Range. And that produces what are called basins, like gigantic bowls to the east of them. This has to do with continental plates colliding. But the end result is that the mountains are a source of sediment, sand, and silt and mud that flows eastward toward onto a coastal plain. And so that river system is a natural track for since plants and that sort of thing. Situations a bit different in Mongolia. Some areas represent extensive dune deposits. So that's where we get the fighting dinosaurs from the Jadakta beds. And there's also river systems, ancient river systems that also preserve dinosaurs. We see that in the Nemegt. That's probably associated with the Altai mountain range, but I'm not an expert on the geology of that area. The geological history of Europe is very interesting and complex. And during the Mesozoic, at least during the later Mesozoic, Europe was often broken up into a system of archipelagos, lagoons, and islands that sort of provided stepping stones between Africa and Asia and what was then to become the Middle East. So there's a bit more of a complicated geological history there that isn't that similar to what we have in North America. So it's just the geological luck of the draw that does control the area of fossilization, and so it's complex. And Europe is a very interesting case. We do have dinosaurs. There's a great fossil record in Romania. We've got fossils in Belgium, the UK, and beyond. And so it's not like there isn't anything in Europe. And what is in Europe captures quite a complete swath of the history of life on Earth. And it's as important as any other region of the world, even if, say, people aren't, finding Triceratops-like skeletons all over the place. The European record is as vital and as important as any other on the planet.
Yeah, I actually read, I don't know if it was recent, but I think it was fairly recent. There was fossils of one of Titanosaurus found somewhere in Spain, and now people were thinking about is that actually the origin place for those kind of species of dinosaurs?
From the regions of Portugal, Spain, and France, there's excellent Mesozoic fossil record there, and a lot of different types of dinosaurs and different types of fossils. Everything from the skeletons that you described to eggs and nests. So there are particular regions in Europe that are very productive in the way that we imagine the American West or Central Asia.
Yeah. Well, you are most known for your studies about T-Rex. We mentioned T-Rex earlier, in particular about their growth. Where you concluded in your study, if I'm correct, that weight and height of T-Rex isn't correlated to their age, right? If I understood that correctly. Can you give me more insights about it?
Right. So the T-Rex fossil record is an interesting one. We have many adult specimens. We have very few juveniles and subadults. So we have a biased fossil record there and a distorted picture of its development. But what my results found back in 2020 is that among the adults, there is quite a bit of variation in size, which means variation in mass. And that means that among these animals that are, say, 35 to 42 feet long, there's a lot of variation. And there isn't a tight correlation between size and maturity or mass and maturity. And that's something that we should expect anyway, right? So if we had a bunch of grown-up people in a room, we wouldn't expect everyone would be the same height or the same weight. So T-Rex is following the rules of other animals that have, something like determinate growth. They do reach a plateau, and there's variation there. That's what we should expect to see. But what's interesting is in the earlier stages of growth, we do see that correlation, as we do, in all other animals. They start small, and unless there's something developmental at play, they get larger till they mature.
Mm-hmm. And what about the talk that T-Rex should be divided into 3 different species? T-Rex, Tyrannosaurus imperator, and Tyrannosaurus regina. What about that? Because it kind of brought uproar in the paleontology community.
Yes, so I led a team that was critical of that hypothesis. And, at the bottom line is that the features that work pointed out as species specific really weren't. They're really part of the variation that we see, in a population. Also, that the features that were claimed to be distinct weren't. Some individuals of one species had the distinct features of another, and it was just overall just a very weak hypothesis. It doesn't mean it isn't true, but here we have a special bind with dinosaurs in general, is that the sample size is not very good. So for T-Rex to really understand variation, we would need between 70 and 100 half-decent skeletons and skulls to answer a basic question like, can you tell the difference between males and females? And we're nowhere near that. We're not in a very good position to really understand the details as much as we would like to. And that includes whether or not there's more than one species in the sample that we do have. And so far, I've seen no evidence to indicate that there's any, that there's more than one species. I've seen T-Rex specimens from the bottom of the Hell Creek Formation and from close to the top, and there's nothing that leaps out to me that they're anything different. Tyrannosaur variation can be very subtle, but when species variation is there, it's consistent, and it's seen throughout the growth series. And so I'm not persuaded that there's 3 species. I think all the evidence shows that there's only one. And also, while we're on the topic, I'll say that the one that was recently named in New Mexico, I've been on the record saying I'm not persuaded by that either. I think it's just another T-Rex. So the end of the Cretaceous was a unique time. T-Rex was probably an invasive species from Asia. And it really did change the ecosystem. In previous stages of the Cretaceous, there was, maybe a couple Tyrannosaurs running around in the American West, and T-Rex was the only one at the end. It was big, Its ties were in Asia. I think it lived in a different environment, had a different type of prey. And that meant that it might, that it was, had consequences for the ecosystem of the American West at the end. And we don't know if T-Rex made the earlier tyrannosaurs that were already there extinct. The fossil record doesn't capture that. Fossil record actually doesn't capture much. So we don't know the impact of T-Rex, but we know that the world of T-Rex was different and that we have only one species, one top predator. And that's something that we might never get an answer to in terms of how and why. But we'll keep collecting skeletons in the meantime.
One bone at a time. Is there, how much do you think actually, maybe it's a little bit of a dumb question, but I don't know, how much do you think fossils we have left? Sort of, how much do you digging there's still left to do, in your opinion, just in general? How much do you think we haven't discovered yet about dinosaurs that we would be able to?
Right, that's a really good question. And one of my colleagues at the Royal Tyrrell Museum of Paleontology, as it is now called, named Don Henderson, Don took a stab at estimating that for, I think, Dinosaur Park. Now, I don't recall the exact numbers, but you can look that article up, out Don's. But I can tell you just from the area that I collect, where I collect in southeastern Montana, it's obvious that, we have centuries of field work ahead of us.
Oh, yeah.
Yeah. Like, I'll be, long dead until, before those fossils collected from our field area. It's just the volume of sediments is so immense, and the relatively high frequency of fossils within that sediment is so high, relatively speaking, that it'll be generations before anything's exhausted. And what does happen is an area can be overpicked. And so in our own area, we focus on several different areas. And if we're in one area for field season and we go back the next summer, there usually isn't much to find. But if we go to an area that we haven't been for a couple of years or have never been to, the new fossils will come to surface. They'll erode, right? Erosion exposes those. So regardless, I would say it's inexhaustible in the American West. And probably that goes globally as well.
Yeah, there's this article about this study in 2006, estimated that around 71% of dinosaurs remained unknown. We are talking just about dinosaurs, what about other species and everything that we won't be able to uncover, and the stuff that will take centuries, like you said.
Right. And also, we don't only collect dinosaurs. I want to know everything about our area of the Hell Creek Formation, how it compares regionally to the Dakotas and northeastern Montana and beyond. And so we collect everything. We're collecting the dinosaurs, the fish, the mammals, birds, plants, invertebrates. We want to have a really robust data set for other scientists to work with. And just last summer, I had one of my own students start studying our fish fossils. And what's sort of interesting is we have a couple species of bowfin or dogfish. And I had a student study those bones, and we, for some reason, find a lot of the jaw bones, the dentary, the lower jawbone, that contains most of the teeth. And Joseph started to work on identifying all of our bowfins. There's two species, one's more abundant than the other. We didn't know that. And he's also started to work on on the growth changes of the dentary in those two species. And so I'm looking forward to him presenting his preliminary work at the next STP meeting in Minneapolis, St. Paul. So just the point is that we're interested in more than the dinosaurs. I do have my specific interest, as you know, but everything matters. All the information matters. And with the plants, We work with a paleobotanist from Northern Illinois University named Josh Schwartz, and he joins us and he collects plant fossils. And at the end of the day, we rent a house. And so I'll be sitting at the kitchen table and Josh will come in with a slab of rock, basically set down a forest floor in front of me. And the density of leaves and twigs and even flowers is overwhelming. So the sheer number of plant fossils must be in the billions or trillions.
Oh yeah.
Which far outnumbers the animals.
Yeah.
So, the fossil record is I think a lot more rich than we imagine. And there's a lot that we can learn from it. There's more than just the dinosaurs. There's whole ecosystems there, or not the entire ecosystem, but big parts of it.
Yeah. What I wanted to ask you also, I read recently apparently it was last year, I'm not sure, that there was this dinosaur that belongs to the Tyrannosaur family, and he was found. What was interesting, fossil was found with traces of his last meal in his stomach, and it was some sort of a bird-like dinosaur. And on that note, I wanted to ask you, because I always read that debate. What's the feeding behavior of T-Rex? Is it some say scavenger? Is it more predatory? Like, what's your take on predatory behavior of T-Rex? Does he hunt small prey? Just he's a scavenger? Does he hunt big? Maybe.
Right. So I think the way to approach these questions, we have to consider evolution. We have to consider the family tree, which is technically called a cladogram. In terms of common ancestry, dinosaurs are nested within predatory animals. They aren't nested in a group of plant eaters. So ancestrally, it's clear that we're dealing with a predatory ancestry. Then the question becomes, well, does that switch to something else along the line of T-Rex? And in terms of the basic predatory equipment, the raptorial claws on the hand, the sharp teeth, the high bite forces, and even to some extent lesions like injuries that we see on the heads of these animals in their mouths. I am persuaded that they're ancestrally predatory, and they didn't lose that. And there's no reason to think the T-Rex was a scavenger, although at the same time, there's no reason to think a T-Rex would not eat a carcass. After all, we have large predatory archosaurs alive today, like Nile and saltwater crocodiles, that will, they're out there killing stuff and are also out there ripping arms and heads from carcasses. Just food is food. But I don't agree with the notion that T-Rex was, say, the vulture of its time. I don't see any evidence to suggest that that's the case. But I do think it's important for us to question our assumptions. So I think the idea of a scavenger and the evidence advanced to argue that position is an important reality check. We shouldn't rush in with assumptions. I think that's the larger lesson here. But in terms of common ancestry, anatomy, and to a lesser extent, pathology, injuries, I'm persuaded that they are predatory. And I just want to comment on the fossil you mentioned. That was a juvenile Albertosaurus libratus, lived approximately 74 to 76 million years ago in what is now Alberta. And yet had the hind quarters of a couple Oviraptorosaurians in its stomach. And it surprised me because I always imagined juvenile tyrannosaurs eating their prey whole, right?
Mm-hmm.
They were big enough.
And it bit only the part, right? This one.
Yeah, just the legs. And it's kind of, it gives you, if we're interpreting the fossil correctly, if that is true, then that means that Tyrannosaurus, or at least that one, was a fairly picky eater. And for really dumb animals, that's pretty impressive. I find it quite charming. But
Yeah.
you have to keep in mind that it's only one specimen, right? It's an N equals 1. And so it'll take future discoveries to really understand the foraging habits of those animals. But it's interesting and it has some charm.
We spoke about, with other paleontologists about the theory of mass extinction of the dinosaurs, and I expected to have a common ground there from books and articles and everything. I read movies, documentaries so far, and Philip Curry in particular really tickled my imagination because he's one of those biggest names in paleontology, and he doesn't necessarily agree with the theory of mass extinction and meteor strike, all species dying at the same time and everything. What's your take on the mass extinction?
Right. So mass extinction is not something that I'm involved in studying, but of course, you know, it's an important part of life history.
Lore.
Sorry?
Part of the lore of the dinosaurs there, everybody should know it.
Right. Yeah, exactly. So we have two major events and one big problem. I think the evidence does show that the Deccan volcanism in India did overlap in time with the extinction. If not, I think it precedes it and overlaps. And then we have the meteor strike. So we have empirical evidence for those events occurring together. But the problem is that it's the fossil record. The fossil record is fairly low resolution. We don't really have captured in the fossil record moment by moment the local and global effects of the meteor strike. And I think that's an appropriate place to start. Now, there is the locality in North Dakota called Tanis, which apparently has some bearing on the extinction event, although that's contentious. And so I'm leaving that off the table. I think that the claims of Tanis are currently unresolved and need to be independently tested. So I don't have much to say there. But we do, in general, have a fossil record problem. And I think that we have to be honest with ourselves about that and be very critical of what evidence we do have. It doesn't mean to automatically reject or naively reject. It's just we have to acknowledge the limitations of the evidence we have. Just subjectively, it's hard to imagine that the meteor impact did not cause a rapid and catastrophic cascade of ecological collapse around the world. It's a thing that's hard to grasp. We've never experienced that.
I hope we won't.
Hopefully we never will. It's beyond our experience. It's something hard to grasp. People don't often think in terms of megatons of dynamite, right? Even though we are in the nuclear age and nuclear threat hovers over us constantly, it's hard to really understand the energies involved in the downstream effects of that. So there's an intellectual issue here as well. But it's the evidence we have. It's I think if it's a 1-2 punch, fine. I don't have a dog in the fight. But I'm skeptical that there would have been the mass extinction without the bolide impact.
There are no rules but one. Drink Jägermeister at minus 18 degrees Celsius.
Okay, so we obviously had to ask you about extinction, and you didn't have the horse in that race. But what about the cold versus warm-blooded debate? Do you have a horse there? What's your opinion? Were dinosaurs cold-blooded or warm-blooded?
Right. So we can take the global view what's up with crocodilians and birds, living crocs and birds? Birds are obviously warm-blooded. Crocodilians aren't. And yet, there is some research to show that crocodilians are secondarily cold-blooded, and that it's possible that the archosaur clade itself was ancestrally warm-blooded or somewhere along the track to warm-bloodedness. When we consider the pterosaur dinosaur group, the bone histology, the microstructure of bones, shows that those animals had high growth rates. Dinosaur growth rates are comparable to, if not greater than, living mammals, which are obviously warm-blooded by and large. And so I think the evidence is quite clear there. So evidence comes from common ancestry, also comes from the microstructure of bones themselves that give us an indication of growth rate, and also insulation. So pterosaurs have, well, I'll just take the plunge here. Pterosaurs and dinosaurs share the presence of feathers. Ancestrally, feather structure are basically hollow tubes, and you don't have integumentary insulation unless you need to conserve heat. And animals that produce their own heat metabolically need to trap it. And so I think that's another line of evidence in favor of warm-bloodedness, at least at the level of the ornithodyrans. That's the pterosaur dinosaur clade. And so I think that's fairly uncontroversial. I think, in terms of the bigger picture of the croc bird clade, the archosaurs, I think there's, an interesting story there to really trace out in some detail. I don't think we know as much about ectothermy and endothermy and the evolution of both in the crocodile, although that's not a literature I'm very familiar with, so that's a bit of a gap in my own knowledge. I think the archosaurs are an interesting case study in the evolution of endothermy, and they're a worthwhile comparison with what happened with mammals. The synapsid line. Obviously, animals like the finback dimetrodon were not hot-blooded, and they, like a cheetah or us for that matter. But there is a transition there in pressures that would have pushed that lineage toward warm-bloodedness. So I think that bigger picture story is one I'd like to know more about. But I also think it's not that controversial that at least the dinosaur line among archosaurs was warm-blooded, or the pterosaur dinosaur line.
Mm-hmm.
A quick answer.
Yeah, I want to jump from what happened to what is happening, because probably fueled by your unrelenting passion for dinosaurs, you found yourself among the group of paleontologists who are strong opponents of auctions of fossils for personal collections, right? And what do you think this movement in paleontology circles can achieve, what will achieve?
Right. So I guess I can just discuss a specific case study that I'm working on. I have presented the earlier version of this a few years ago, and currently the final version it's getting put together. So in terms of the fossil market, I think paleontologists, particularly those that work on dinosaurs, don't really understand the impact of the numbers. And so I didn't understand the impact of the commercial trade, really. And so a number of years ago, I started to count. And so I started to count the number of T-Rex fossils in particular that were either privately owned, gone up for auction, sold at auction, this sort of thing, and compared those numbers with the sorts of fossils in museums, public trusts, and just to see how bad is it really? Like, am I alarmed for nothing? or is there a problem here? And what I've found in a nutshell is that the commercial trade has emptied out at more than half the sample size of T-Rex. And so if we were to, wave a magic wand and take all those privately owned T-Rexes and commercially held T-Rexes and put them into museums, we would actually be in a position to answer those basic questions like, can we tell males and females apart? And we can't, because the trade has been that extensive, it has been that lucrative, and it has been that damaging. And I think that's something that, as scientists, we have to take this problem seriously. And as scientists, we prefer just to work on the fossils, do our field work, publish studies, train students, that sort of thing, work on museum exhibits. We don't necessarily want to be all that concerned about the outside world, right? Because we have our own priorities, but the outside world is impinging on the science in a very significant way. And the bottom line is the fossils are the data. We don't have science without data. And say 50 or 60 T-Rex specimens in various stages of completeness, covers, it's mostly adults and a handful of juveniles, will never answer all the questions we want to have answered about T-Rex. We need to build up that sample size to be on the same footing as, say, people who study modern animals. Mm-hmm. And the commercial trade doesn't help. And there's another piece of this, is that ethically, we are obligated to not study fossils that are privately held. Fossils should be in a public trust where, say, I publish a measurement of a T-Rex, a colleague should be able to go to that same fossil, take the same measurement, and make sure I got it right. And that's replication. And replication is the cornerstone of all sciences, whether it's chemistry, physics, ecology, anything you want to consider under the umbrella of science. Replication is the cornerstone, or else, we're vulnerable to people making stuff up. So with our own ethics, we're obligated to not study those fossils because of the replication problem if we do. And so there is a T-Rex that is an example of that problem. There's a commercially held skeleton nicknamed Stan, not in a public trust, and it was sold at auction for $32 million a few years ago.
Wow.
And it's privately owned, and it's not in a museum. And even if it is in a museum, it's claimed that it will be put on loan in a museum, but that means it's still privately owned. It doesn't belong to a museum. It doesn't mean it'll always be there. And so now that set of data, that unique set of data, is gone. And there is a whole bunch of scientific articles that include that fossil. And now no one can go and restudy the fossil to make sure the previous claims are true or not. That's what we don't want to have happen. That's the worst possible outcome of this issue. Mm-hmm. Aside from just fossils disappearing, it's worse that privately owned ones are in the literature.
Go on.
Go ahead.
Are we talking about numbers here about legal market, with auction houses like Sotheby's and similar, or black market, or both of them?
Right. So my focus has been on, as far as I know, the legal market. And just because the market's legal doesn't make it the behavior right or the outcome right. Mm-hmm. So I don't know about the illicit market in dinosaur fossils from the American West. I'm sure there is one. As far as I can see for T-Rex, the black market hasn't touched it, because most of the fossils do come from private land. And so in the United States, the land in the American West is divided into a checkerboard of three types of land. There's public land, which is governed by the federal government. There's state land, and then there's private land. And dinosaur fossils on state and public lands are protected by various laws, federal and state laws. And fossils on private land enjoy no such protection from being sold to just anyone. And so that's where most of these fossils are coming from, is private land, as far as I can tell. But the black market, yeah, I haven't pursued that line. In some ways, I almost don't need to, but I don't have a sense of the black market. Where the black market is a problem is in countries such as Mongolia, where all the fossils there are protected by law. And yet there is, as far as I understand, a fairly steady market in Mongolian dinosaurs, and all those are dirty. Same with Chinese fossils. But that's not been my area of focus currently. I've been really focused on T-Rex, since T-Rex is really hit hard, probably the worst hit by the market. And the numbers are shocking. And there's a fair amount of information about that out there. But, it's a good question, and I just don't know. I haven't looked into it in much detail. But I'm sure there's work on that will happen and will be on the way.
Yeah, I don't know if you look, but I keep thinking about Mark Lawrence, professor of paleontology at the University of Utah. He spoke about the fossil of dueling dinosaurs, Triceratops and T-Rex, fighting and dying together. It's in private, held by private collector. It's going on auction, but he said we're gonna learn a lot more when it goes there. But we won't, will we?
Well, that's an interesting case. So the dueling dinosaurs were purchased by a museum in North Carolina.
Oh, yeah.
They've raised money to purchase those fossils, and they've raised money to a brand new lab, so that the fossils can be prepared on public view. So those fossils did wind up in a public trust. And so we will learn a lot from those. And, there's, so that's, that story could have turned out differently. In my view, it's still not ideal, because I think in terms of the practice of museums purchasing fossils, especially dinosaurs, is I think it matters where the money goes. And so in the case of Sue, Sue is that famous T-Rex that's currently at the Field Museum, the courts decide that Sue belonged to the landowner. The landowner decided to put Sue up for auction, and the money paid for Sue went to the landowner, and the Sotheby's got a cut of it. But as far as I know, none of the money went back to the original commercial company that collected it. And so, and since the money didn't go back into the commercial trade, I have no trouble studying Sue and including it in my research. But I think it's a different story when the money goes from a museum back to the commercial trade and funds it effectively. Those fossils I will not study, because I don't think, there should be a trade in scientifically important specimens. And so on that point, not all my colleagues agree with me, and that's fine. That there will be disagreements, but part of my motivation here is that I'm an educator. I have students, I have volunteers. I set an example for ethical conduct within our science as best that I can. And I really try to align my behavior with the expectations of my science. And so these specific details, aren't dealt with necessarily But we do have to grapple with them as individual scientists. And this is where I've landed, and not everyone else has.
Yeah. Are you, final one for me, are you familiar with John Reeves and Boneyard Alaska?
Fill me in.
Yeah, he was a guest a couple of times on Joe Rogan's podcast. He has big lands in Alaska, covered in permafrost, where he found, as he claimed, tons of fossils of mammoths and dinosaurs, etc., etc. But what I wanted to talk about, we obviously now can't, is about his claims that allegedly American National Museum of History got in the 40s 50 tons of fossils, which they allegedly dumped into, was it Hudson?
Yeah, something like that.
Yeah, and that were his claims. They couldn't research it, etc. I can send you links so you can check it out. It's interesting. He is not paleontologist, but he has done a lot for the popularity and awareness for paleontology.
Sure. Yeah, I don't know about that particular case. History of paleontology, past, present, and future, we'll have a lot of, sketchy stories, whether they're true or not, we may never know. But vertebrate paleontology is not immune to the frailties of the human mind and behavior.
Well, if you could sell something for 32 million, it would be very hard to say no.
But yeah, go ahead.
Well, that was it from us. That was all questions I had in my rifle. Thank you for coming. It was really interesting to have your scientific take on everything.
Well, thank you very much for inviting me. I appreciate it.
Yeah, I hope you enjoyed your time with us.
Oh, I did.
Yeah. But before we completely wrap up, we have a little tradition where we say a quote on our language, Montenegrin, and translate it to English. And Luka has prepared a quote for this episode.
Okay, the quote is from our neighboring country, Serbian geographer Jovan Cvijić, and he said on our language, mi nesrazmjerno više govorimo nego što radimo. Mnogi imaju tu osobinu da misle da su radili kad su govorili. And in English it would translate to, we talk more disproportionately than we do. Many have that characteristic of thinking that they have done something when they have only talked.
Not intended for you, of course.
I agree. I've sometimes told people it's more impressive to hear about what they've done instead of what they plan to do.
Oh, yeah. A lesson for all of us.
Yeah. Thank you for coming once again.
Thank you.
We stay genuine, uncensored, and unscripted, and we always will, as we have to order our usual. Share us and subscribe us, and stay tuned until the next Wednesday. IKUZO!